Good morning, students. In today's concept, we want to learn what is equilibrium and the points related to equilibrium we want to learn now. So, the definition of equilibrium you see. When a number of forces acts on a particle and produces zero acceleration. So, when a number of forces acts on a particle and produces zero acceleration, then the particle is said to be in equilibrium. So, equilibrium means resultant force. Equilibrium means resultant force on it is zero. So equilibrium means resultant force on it is zero. The resultant force on it must be zero. So resultant means F net is equal to 0. So that is F net is equal to 0. That implies A net is equal to 0. Net acceleration is equal to 0. Or simply you can call acceleration is equal to 0. If I consider this is a particle, okay students, and the number of forces acting on the particle, this is the particle. So like so many forces are acting on the particle, okay. These are all forces acting on the particle. Okay students, so when n number of forces acts on a particle and produces zero acceleration, then the particle is said to be in equilibrium. Equilibrium means acceleration of the particle is equal to 0. So the sum of all the forces is equal to 0. So that is the first point. And the second point is single force. Single force cannot keep the particle. Single force cannot keep the particle in equilibrium. So single force will never exist in the universe, and a single force cannot keep the particle in equilibrium. Suppose if I consider I hold this duster in my right hand. This is the duster, I hold it in my right hand. Okay students, sorry, in my hand I hold it. Okay, now you see students, its weight is acting downward direction. So normal reaction by my hand on the duster will be upward direction. And even you can consider air this side exerts some force on it, and air this side exerts some force on it. And these air molecules, and the atmosphere will exert some pressure on it, means some force on it will be there. Means so many number of forces will act on the particle. If the sum of all the forces acting on the particle or the point or the object is equal to 0, then we say that the object is in equilibrium. In that situation, we say that the object is in equilibrium. Single force will never exist, and single force cannot keep the particle in equilibrium also. Okay students, that is the second point. And third point, minimum number of coplanar forces. Minimum number of coplanar forces required minimum number of coplanar forces required to keep the particle at rest. To keep the particle at rest are 2. So the minimum number of coplanar forces required to keep the particle at rest are 2. Suppose if you consider this is a particle, this is one force and this is another force. Like two forces are acting on it. Okay, students. So F1 is the force and F2 is the another force. F1 and F2 are the two forces which are equal in magnitude, opposite in directions. Minimum number of coplanar forces. So which are equal in magnitude, opposite directions. So then the net force on it will be 0. Then we say that object is said to be in equilibrium. Okay, students, means minimum number of equal and coplanar forces. Minimum number of forces which are equal. So you can call equal also. So equal in magnitude. So the magnitude of F1 is same as that of F2. Magnitude of F1 is equal to magnitude of F2, but the directions are different. So means if F2 is left side, F1 is right side. So the resultant force on it will be 0. We will say the object is said to be in equilibrium. And similarly, next point, minimum number of unequal coplanar forces. Minimum number of unequal coplanar forces. Minimum number of unequal coplanar forces required. Minimum number of unequal coplanar forces required So minimum number of unequal coplanar forces required to keep a particle at rest are 3. So minimum number of unequal coplanar forces required to keep a particle at rest are 3. So coplanar means lying in the same plane. So remember students, coplanar means lies in the same plane. Coplanar means the forces which are lying in the same plane. Okay, students. So that is called a flat surface. That plane means it is a flat. It is a flat surface. Okay, students. Now this is a point. So and this is one force, and this is another force. So this is the first force F1, this is the second force F2, and consider this is the third force F3. So the resultant of F1 and F2, the resultant of F1 and F2 forces is balanced by F3. So the resultant of F1 and F2 is balanced by F3. Or resultant of these two is balanced by this one. The resultant of any two forces balances the other. So the resultant of any two forces balances the third one. So the particle is said to be in equilibrium. So this is the plane I am considering. This is the plane I am considering, students. This is the flat surface that is called plane. So minimum number of unequal coplanar forces required to keep a particle at rest are 3. So that is about fourth point. Next one. So next one, fourth point. So minimum number of unequal non-coplanar forces. So minimum number of, what is that, see students? Minimum number of non-coplanar forces which can keep a particle in equilibrium are 4. So if the forces are not lying in the plane, if the forces are not lying in the same plane, so then minimum number of non-coplanar forces which are not lying in the same plane, minimum required are 4 forces are required. So to keep the particle at rest. So that is about non-coplanar forces, 4 is required. Over. And next one, what is equilibrium? So equilibrium we have seen. The next one is equilibrium. So equilibrium. When a single force balances a set of forces, when a single force balances a set of forces which acts in the same particle, then that single force is called equilibrium. So the single force is called equilibrium, and this equilibrium force is equal in magnitude opposite direction to the resultant force. So see students, this is a particle, and this is one force. This is one force. Let this force be F1, and this is another force. So F2, and this is F3. Now see students, now there is a force. So now there is a force. I am calling this is F, a single force which balances the set of forces. 2 or more forces called set of forces acts on the particle. These are called, what is this? These are called set of forces. So a set of forces, a single force which balances the set of force. Okay, the set of forces, the resultant of all these. Okay, so the resultant of all these R is equal to, so F1 plus F2 plus F3. This is the resultant force. This is the resultant force R bar. This resultant force, okay, that is called, this is the equilibrium force. Here the name of F is equilibrium force. The name of F is called equilibrium force, and this equilibrium force is balancing the resultant of some set of forces which are acting on the same point, then this single force is called equilibrium. Then the particle is said to be in equilibrium, and that force is called equilibrium, or it is called equilibrium force. The equilibrium force magnitude is equal to magnitude of resultant force. So the equilibrium force magnitude is equal to magnitude of the resultant force, but in opposite direction. So means if this is the direction of F bar, the resultant force direction will be opposite to this one. Okay students, that is about equilibrium and resultant forces. So the next one is and the next one is when a number of forces acts on a particle, when a number of coplanar forces. So the next point is 8th one. You see what is 8th point, you see students. When a number of coplanar forces acts on a particle and the particle is at rest. So some n number of coplanar forces are there. So for example, n number of coplanar forces, n number of coplanar forces. So n number of coplanar forces acts on a particle and keeps a particle in equilibrium. N number of coplanar forces keeping n number of coplanar forces keeping the particle, n number of coplanar forces keeping the particle in equilibrium. So n number of coplanar forces keeping the particle in equilibrium. So then algebraic sum of the forces in the x direction must be 0. So that is sigma fx is equal to 0 and the algebraic sum of all the forces acting on the particle in the y direction is equal to 0. Means here the plane I am considering as xy plane. So the total sum of all the forces in the x direction and the total sum of forces in the y direction must be 0. So that is sigma fx is equal to 0 and what are you writing? Sigma fy is equal to 0. This is the 8th point. And next 9th one is, so and the next 9th point is, what is that you see students? When n number of coplanar forces are acting, and the particle is not in equilibrium. So n number of coplanar forces acting on a particle n number of coplanar forces acting on a particle and F net is not equal to 0 and F net and what is that? F net is not equal to 0 means the particle has some resultant experiencing some resultant force, means it has some resultant acceleration. Then that net force we will write it as, then that net force, that F we will write it as, so then that F we will write it as Fx into I cap plus, what will you write students? Fy into j cap will write. This is called F bar, that F bar equal to Fx into I cap plus Fy into j cap. Okay students, here, so what will write? Fx is equal to, so vector sum of all the forces in the x direction. first vector x component plus second vector x component plus third vector x component plus so on plus nth vector x component. So this fx is equal to, you should write the components of all the forces. Okay, in the x direction we have written, so there is no need of bar. And similarly, so write the components of all the forces acting on the particle in the y direction, Fy, that is called F1y plus, so F2y plus F3y plus so on plus Fny. These are all the so means here this Fy value is equal to first vector component along y axis, second vector component along y axis, third vector component along the y axis. So means we are writing the sum of all the vector components along y axis plus the sum of all the vector components in the x direction also we are writing. Okay students, this is the net force. If we want its magnitude, so if we want its magnitude, then F is equal to what to write students? Fx square plus Fy square. This is called magnitude of that resultant force. So magnitude of this resultant force means this x component I coefficient square plus j coefficient square will write it. Okay, so simply here there is no need of bar. Magnitude of resultant force. So magnitude of resultant force, that is called F, and its magnitude we will write it as, so I coefficient square Fx square plus j coefficient square Fy square. Okay students, so this is about F bar. Okay students, okay students, we can discuss some problems based on equilibrium. Okay students, in the preliminary result level, so question number 54 you see students, the minimum number of forces equal in magnitude in a plane that can keep a particle in equilibrium is, okay, so answer is 2, option also 2. So the 54 answer is 2. So go through this question. And next question students, next question 55. So minimum number of unequal forces, minimum number of unequal forces in a plane that can keep a particle in equilibrium is, so answer is 3 and option also 3. Option also 3. So 55, question number 55. So answer is 3 students. Okay, and similarly you see question number 56. The minimum number of non-coplanar forces. Question number 56. Minimum number of non-coplanar forces that can keep a particle in equilibrium is asking. So we know that 54 option is 4. 54 correct answer option 4. Answer also 4. So minimum number of non-coplanar forces required to keep a particle at rest is 4. So these are the 3 bits we have in preliminary level. Now I'll go for a mains level. In the mains level, so Problem number 97. Mains level, problem number 97. So what is the 97th problem? You see, students, three forces act simultaneously on a particle. Three forces acting simultaneously on a particle, and the particle is in equilibrium. Then the value of A they are asking. Since particle is in equilibrium, the vector sum of all the forces must be is equal to 0. So what am I? Since the particle is in equilibrium, since the particle is in equilibrium, the vector sum of the three forces must be is equal to 0. So the vector sum of three forces the vector sum of what is that? Three forces the vector sum of three forces must be equal to, okay, what is that, students? 0. So that is F net is equal to, so that the net force means F is equal to, I am writing F1. So F1 is A into I cap plus J cap plus, so A into I cap minus J cap plus K cap. This is the first vector, and the second vector is 2I cap minus 3J cap plus 4K cap. This is the second force. Plus third force he has given 8I cap minus 7J cap plus 6K cap. So this must be is equal to 0. So he told three forces are acting. First force, second force and third force. Three forces acts on a particle and keeping the particle at rest. Three coplanar forces he has given. Three forces acting simultaneously. No need of a coplanar. And keeping the particle at rest he is telling. And keeps the particle at rest means that force must be equal to 0. So I have written that. Now I am adding. So I want to take the I cap common. So all I coefficients are writing. So if you take I cap common, A is left, and you take I cap common, plus 2 is left, and you take I cap common here, so plus 8 is left. Okay, students. And similarly, J cap you take it common here. J cap A into. So I am taking plus J cap common. So A into minus 1, you will have minus J plus, and if you take J cap common here, minus 3, and J cap common here, minus 7 plus K cap is equal to, so K coefficient, K cap you are taking common, A into 1, so A, and here K cap, K is you take it common, 4 is left, and here k cap common plus 6 is left. So that is equal to 0. This is the force F bar. Then F bar is equal to, so what you write? I cap into A plus 2 plus 8 10 plus J cap into minus A minus 3 minus 7 minus 10 plus K cap into 4 plus 6 10. So is equal to 0. This I want to write 0 into I cap plus 0 into J cap plus 0 into K cap. Now equating I cap coefficients on either side. Equating I cap coefficients on equating coefficients of I cap, J cap and K cap on either side. So on either side, you equate the coefficients of I cap, J cap and K cap on either side. So here I cap coefficient is A plus 10, that is equal to A plus 10 is equal to 0. I cap coefficient A plus 10. Here I cap coefficient 0. And next here J cap coefficient minus A minus 10, and here J cap coefficient is equal to 0, and here K cap coefficient A plus 10, and here K cap coefficient is equal to 0. Then this A you take it, A plus 10 is equal to 0, so then A is equal to minus 10, and here also minus A is equal to 10, and right here also A plus 10 is equal to 0, and here also you write A is equal to minus 10. So they asked the value of A only. So we got the A value as 10, or here anyway we got the value A 10. So this is the given problem, students. See, 3 vectors they have given, and these are all acting on the same particle, and the particle is in equilibrium. So then find the value of A they have asked. So since the particle is in equilibrium, sum of all the forces must be 0. We have equated that to 0. The 0 we have written like this. Then we got the answer. Okay students, now we can go for next problem.